Welcome to our second session of the day on understanding the material fingerprint and fiber traceability with Tobias Herzog, the Managing Director of Tailorlux. Tobias is going to share some user cases with us to help us understand how physical tracers and digital solutions are basically the same, are one side of the same coin and should be implemented as part of the end-to-end solution. So over to you, Tobias, and we'll circle back again for some questions after the presentation is done. For attendees, if you have any question, there's a submit your question option on the live stream. Please click on that and submit your question, and we'll pick them up in the end. Over to you, Tobias.
All right, thank you very much. I was thinking of starting with a short demo with this device, but I actually just decided to not get caught up in changing the screen between the PowerPoint and the live show. So I'm just going to share my screen, do the presentation, and afterwards we're going to have a small demo of the device. So you should see my full screen now. And as it is here catched in the first slide, we will talk about material fingerprints. And we consider this as being the back end of digital traceability. And when I look at the agenda of the sessions that you already heard, there are lots of digital aspects to it. And I would like to shed a light on the material side of this, because, yeah, as Chinky said, we think that's two sides of the same coin. Yeah, why does this really matter? I mean, this is something that is quite obvious. Material does matter in supply chains. So we do not really see what we are sourcing beyond tier 1, because we don't know always, we are not really sure where the material is coming from. Is this really organic cotton? Is this really recycled PET, for example? And I would like to show a technology that makes this impact that a material can have visible. So we would like to distinguish, for example, what this yarn really is. Is it 25% recycled cotton? Is it 50% recycled cotton? And who was actually producing this? And this is the use case. And I think there are many other aspects. We can now talk about the European initiative towards the digital product passport, or why recycling matters and so on. But I think that you heard this already a lot. So I will just focus on the material and the technology side in order to show you what tools are available to connect the digital and the physical world with one technology, which is spectroscopy in this case. So we have, yeah, like the two coins of one coin and two sides of it, the digital and physical. We have a material flow that goes into a digital traceability system, and we want to think circular, so there's obviously also waste coming back. And when we have digital traceability technologies, we talk about document management systems, digital twins, labels, geolocations, and maybe even an interface into your enterprise resource planning to get data and visualize data of what is happening in your supply chain. But the physical part of it is somehow missing, because the material does not have an input yet into this data. So we would like to connect this with data about, for example, contamination of waste, the origin, so where does it come from? So we are adding a tracer to it, an inorganic tracer to track the origin, or we want to just see what is the material blend of what we have, or what we want to discard, what we want to turn into a new material by a recycling process. And this can be done with this wonderful device with handheld spectroscopy. So what you here see is the newest development of Tailorlux. it's an integrated visual and near-infrared handheld spectrometer that can detect tracers as well as materials without a tracer. So what we have is a handheld detection of tracers in many ways. We have a production monitoring tool, which is a software that comes together with this device. So you can actually monitor how your tracer was implemented. We have an IoT integration, so you can also do this inline and get data directly from the production line. And this is completely new, we will also push into the direction of chemometrics, where we can distinguish materials based on their absorption curve. So we can see that this is a PET or this is a PET cotton blend. And we are currently creating a library on this in order to use this handheld in the production line or during sorting processes, during quality processes, especially in recycled cotton. Of course, you can use this also to secure or to have security features on QR codes with special inks, or using it in security seals that are protecting your goods, whatever. This is also possible. And of course, we can connect it to a smartphone, so it has a Bluetooth interface, so that we also have all these sensors of the smartphone available to have the user ID, the geolocalization, or whatever. The process that we foresee for all the materials that come into a supply chain is firstly looking at chemometric features. So we are looking at things that are visible in the spectrum with a spectrometer without a tracer, without adding anything. And there are some special materials that have a material fingerprint, which of course does not sustain throughout the complete supply chain. But of course, you can, for example, distinguish wool from different parts of a country, or you can even distinguish cotton, raw cotton. But maybe you want to track it further, and then you have to add an invisible tracer to it to have this spectrometric analysis again, and making your products basically machine readable. And this is why we think that this is the connection. The spectrometer, or the spectra of a product, the material fingerprint, is the connection from the physical to the digital assets of traceability. So how does that work? How is this actually the back end of a digital traceability? We have a pair here. This is the device, the TailorScan 4, the spectrometer together with a smartphone and the smartphone app, in order to have access to near-infrared reference data, so that we actually teach the device already how does a PET fabric look like in black, in red, or maybe you have a wool or a cotton blend, and all these spectral references are stored in a data pool that can be accessed, as well as all the additive tracers, the so-called spectral fingerprints, are also stored in one central database that you can download in order to have access to the material fingerprint, if you are allowed to. So not every manufacturer will share its fingerprint, but it's kind of a key and lock system to have access to material. Of course, this material or the scans of the device can then be embedded into all the data sets that are available with the smartphone, in order to give this to third-party platforms like blockchain providers, track and trace solution, digital twin providers, whatever. A very good example will come right after this presentation with Koen from Aware, where they are already using this to integrate it into a blockchain solution. But I don't want to, I will let him talk about this. What is very important when you are working with tracers to track the origin is that the input of the tracer is securely monitored and documented. And this is something that I would like to highlight here with two examples, one in PET and the other one in recycled cotton. So when we want to create a digital asset, a digital twin, for example, with an additive tracer, we have to make sure that not just everybody is using the tracer. So for example, if I have a tracer from a specific manufacturer of PET, I want to make sure that only his or her extrusion line will produce the marked goods and that the tracer is applied in the right way. We are using a Medex pump, for example, that already has an IoT interface. So we can monitor how much tracer was actually added in order to create the digital twins that are needed, big bags or whatever, or maybe yarn if you directly put it into a yarn extrusion line. And then you can scan and validate this data in the field in order, again, to make this available to third-party software systems. So this manufacturer received this amount of tracer. He actually used it in the extrusion line, so he can claim to have this amount of digital twins or digital assets like big bags, pallets, kilos, whatever you or whatever your item is. Another example is in recycled cotton, where we are using a dosing device. This is a dosing device from Recover, where we are monitoring the data. And here you see the original interface of the machine. Yeah, it looks a little bit from the 80s, but this is how the machinery looks like on the display. So we can monitor the rounds per minute in order to see how much of these tracer fibers has been dosed to the actual process. And this works with a dosing device that we have developed to be sure that when the shredding machine is working, also the dosing device can only work when the shredding machine is working. And we are dosing the exact amount of tracer fibers, which are then used to claim bales of recycled cotton. And then you can verify this in the field, so you can scan a single bale, but you can also scan later on in the fabric that was made or in the garment that was made, and also to quantify this. So we are currently developing a quantification test with Eurofins, which is our verification partner, to offer this recycled cotton quantification service worldwide, so that when you use a Recover recycled cotton fiber, you can actually prove that it is in your yarn, but also that there is enough of this recycled cotton in the yarn. So what we have done is, and here are these two sides of the same coin again. We have a physical asset, a tracer fiber, that was added under remote control of Tailorlux to a process in order to create digital twins or items, which are bales in this example. And then, of course, you can add all these things that you know from digital traceability. So we could put an QR code on this. We can track things with an NFC, but we always have the backup of the material side that this is really physically traceable. So we think that the device is really the key, that spectroscopic analysis is really the key to connect physical and digital traceability with the so-called material fingerprints, which can be created artificially by an added tracer or a fingerprint that is already there by using chemometrics or near-infrared spectroscopy. So we are actually making products or materials talk. And this concludes my presentation. Thank you very much for your attention.
Thank you, Tobias. That was interesting. Do you want to show the demo?
Of course.
Before we dive into questions, yeah.
So yeah, of course, I don't want to talk about a device so long and not present it. So let's fire it up. This is the Tailor 4 uploading, a spectrometer that has 2 spectrometers inside, basically. So we are talking about visual and near-infrared spectroscopy, and they are manufactured in a with a so-called Liga technology. That means every device is the same. So we can actually source from the same data pool and have all these devices in the field and give them access to the data pool. So this is black PET. That's what I think. So we can scan it. So I don't think, yeah, you can see it like this. So yeah, we can see that this is black PET. And now I can also go to the software and change the fingerprints that I want to see. So I'm downloading different fingerprints. I'm connecting the device. Let me share my screen again. So I'm connecting the device to it, because what you have seen now is just a one button device. And this is how we designed it. We wanted to give access to spectroscopy for everybody. So everybody should be able to use this device with just one button. But of course, production people, they want to know more. So you can take a look at your device and also see the library of materials that you have there. And you can also go and just check on the measurement. So if you, for example, are in a production line, you want to see, okay, how this is matching with my reference data. What is the signal intensity of this? For example, to detect blends in melted yarns. With tracer fibers, it's a little bit different. It's a little bit more complex. But I can also just upload different fingerprints to it. So I have Spanish cotton from our Spanish cotton project. I'm uploading it. It's now on this device. I disconnect it, and now I can scan this with the device. So I'm able to have an access to a complete library of materials. I download it to my spectrometer, and I can send anyone to the field with just one button in order to check the material and check whether the material is really the material that I received on a transaction certification, for example.
Just on the material library side, how many materials do you already have in the library?
So we have a variety of PET, of cashmere and cotton. And we are also currently in a program where we want to find out, it's not yet that this one is ready, but we would like to see whether there are differences in recycled PET and virgin PET, because the polymer chain is shorter, and this should create another absorption curve. So we are looking for a chemometric feature that can give us an indication whether this is really virgin PET or really recycled PET or not. So these are ongoing experiments that we are doing. We are in different projects where we just gather more and more material data to enlarge this library as much as possible.
Okay, just because you mentioned cotton previously, there's a question, and they're asking, through this device, can you detect the blend between, say, for example, US cotton being mixed with Chinese cotton? Does the device distinguish between mixing of cotton fibers?
No, I think that the chemometric fingerprint, so if we do not talk about the tracer, that it is not possible to detect this blend, because the chemometric features will be gone after the first treatment of this cotton. And I don't think that you can just, or that for any reason you mixture raw US and Chinese cotton. There is no, I don't think there is any sense to do that.
Okay, all right. And in terms of, there's another question on the recycle side. So with recycled cotton, how would this technology work if the recycled fiber already has a tracer before shedding? Like, can you end up with multiple tracers in a single product?
Yes. So we made some tests with that, and of course, if you're adding an inorganic tracer, it's inorganic. It will stay there forever. The likelihood of materials, even if we raise the recycling quota dramatically, but the likelihood of traceable yarns, let's say with an Egypt cotton tracer, an organic cotton tracer, that they all end up at the same recycling plant to give us a significant signal is more than unlikely. However, we think that there will be ambitious recycling quotas in the future, so this might happen. And what this device does is that it has a so-called scan to hit modus. That means we are scanning over a fabric, and maybe we see residues of an Egyptian cotton tracer or an organic cotton tracer, but the predominant signature in this fabric is recycled. Then it is, for example, recycled by recover, because we can see that this is the predominant tracer in the fabric.
You've mentioned recover fibers. Do you have a partnership with them? They're working with your technology?
Yes, recover is actually using the fiber dosing device, and that was let's say a special challenge, because the throughput of tracer fibers are of recycled fibers are relatively low. So you have to dose a 2-digit number in grams per hour very exactly in order to also make the quantification later on. This cannot be like a process where you just dose it by hand. This has to be very exact in order to have a homogeneous blend, and to also be able to have a quantification model later on to detect the blends.
On dosage, because you just mentioned, there's a question from one of our attendees. What's the normal dosage for your tracers on cotton, and can you detect in color black or indigo yarns?
Yes, we can detect in, so we are talking about cotton still, right?
Yes.
Yes, we can detect in black as well as in indigo. We had problems in the past that the tracer fiber was completely coated. So there are processes, for example, that is, I think it's called over dye, when you have an indigo dye and then you dye over the indigo. Then it's actually like a physical barrier to the tracer. That means the tracer cannot be detected by the handheld anymore. By the way, if you stone wash or bleach, then it's again detectable. But in this case, only a destructive test will help. And this is what we are doing with Eurofins.
And a question on the commercial side, I would say, because we understand going to full scale with a tracer technology in the supply chain could be expensive. But if a brand, forget about brand, a manufacturer who wants to promote themselves with traceable fibers, what percentage cost, if we can put a percentage there, would be for the tracer technology, like the chemical tracer, and implementing a solution like yours? What percentage of
we see this as cost per kilo of yarn, and this differs because, for example, as a manufacturer, and this is a very good example on how traceability works, because the main intention for manufacturers that we are working with is actually not traceability the way that brands think traceability works. It's just that I'm bringing out a material that I'm responsible for, and I don't want to be responsible for material that I did not produce. So I want to see whether it's mine or not. In this case, we are talking about forensic features. like very low dosages that can only be detected with a destructive test. And then it's, yeah, like, I don't know, 2-3 cents per kilo of yarn. If we talk about a full-scale traceability, that also comes with a digital part to it. And I don't know what the cost of the digital parts are, but then we are easily between 6 to 10 cents per kilo of yarn, depending on what the use case is. So how do we have to protect the tracer, for example, against indigo and other materials?
And the cost range that you're giving, it's agnostic of the fiber type, or is this just for cotton?
That was just the tracer fiber. When we talk about PET, it has to be volume. So that is really depending on volumes, and then we can achieve similar price ranges.
Sure. Another question from the attendee is, what is the percentage of precision and error involved in detecting unwanted blends? Like, has this technology been utilized, if you can share this, in any of the brands or manufacturers in the US? And what happens if US gins adopt this technology, but the spinners do not? In that case, will the finished shirt be able to detect unwanted blends?
Yeah, that's a very interesting question, because I was attending the WIGA Labor Prevention Act in Washington. This was an event from the Customs and Border Protection Administration. And we had this question, and I'm currently in contact with the Customs and Border Protection Service in order to get this evaluated on how to create a detection rate. We know this from the automotive industry. So we have a strong footprint in the automotive industry, where this is a question of quality management. So how many measurements do you make, and what is the false positive rate on it? And it has to be close to 0, of course. And this is something that we would like to find out together with the CPP on yarns, actually.
Just based on when you started your presentation, you did talk about the legislation, the digital product passport that's coming, right? You touched upon that. That is also linked to, sustainability angle, right? We say sustainability, traceability is essential in order to achieve sustainable claims that brands are making. Now, do you think the whole discussion around carbon footprints is also a key element? There could be a way in your technology to even show the carbon footprint of those fibers, like if it's recycled PET, what the carbon footprint is, if it's cotton.
Yes, I think it is like I said on the same slide, that materials really matter, because it is beyond tier 1 where the carbon footprint is created. So when something is on the tier 1 level, then I think there's not much leverage to have an input on the CO2 emission. So it's really depending on where am I sourcing and what material am I sourcing. And I think that the legislation plays a major role in this, because we need a standard, we need definitions for it. But that is not something where Tailorlux is seeing itself. We are more positioned as the technology provider that is really connecting the dots A, B, and C, and whatever that means in terms of carbon footprint, that decision has to be made by someone else.
Okay. And you've just said how you see yourself as connecting the dots from A to C, the supply chain. We've had some other technology solution providers yesterday, today, and we also have some tomorrow. What would you say is a differentiator for Tailorlux, or where your strength lies, I would say? So
our strength is really, let's say, on the manufacturer level, that we are looking at it from a very technical point of view, so that the implementation the sensor handling, and all these, let's say, minor things that can go wrong, that these things are managed by us, and we are helping with the implementation. And then it's mostly on the manufacturer level that people say, okay, I want to show that this is my fiber, and this fiber has a specific benefit or specific impact, and I want to show it in the field. I don't want to show it in a lab. Maybe I also need this third-party verification, which we can also offer by Eurofins, but essentially I want to know it for myself and detect it right on the spot. And I think that's the major strength of this technology, but also the near-infrared part that we are now launching will give more benefit, especially to recycling, to the let's say circular economy when taking stuff back.
Okay, talking about recycling. So on the tracer, the chemical tracer, when it's added, does it impact the recycling process, or there's any pre-treatment they need to do before it goes into recycling?
No. So we talk about different recycling processes. Let's start with a mechanical one. Mechanical recycling is not doing anything. That's why we also have to deal with residues, so that the Egyptian cotton or the organic cotton signal might survive a mechanical recycling process. A mechanical recycling process. The chemical recycling process is different depending on the actual process. We made different tests, but when you are creating monomers, the tracers are actually filtered out. And this is a current project that we are where we are trying to see whether we can use this tracer again, so that we can make the tracer actually circular. But this is also ongoing. But for the chemical process, the chemical recycling, we will lose the tracer in the monomer stage.
Okay, so it's easy to recycle. There's no disadvantage using a tracer. You mentioned you're working with manufacturers rather than the push coming from brands, that they want to know. It's about manufacturers telling, this is my product, this is the fiber I'm working with. And these are tier 1, tier 2 suppliers, and sometimes even, farmers, because if it's cotton, you really need to know which farm it's coming from. What are the adoption barriers when you started with the project? You were seeing with the technology, like why people are not adopting, and has that perception changed over the last couple of years, especially the whole regulation push has come in? Has that perception changed?
I don't know why the adoption is not as fast as I anticipated it. Maybe we are just bad at marketing. That could be one reason. And I think that there also is always a slightly different intention to make goods traceable. For example, when we started the Spanish cotton project is also to have an incentive for the farmers to digitize seeds and then to later track also garments. And I thought this is the perfect nearshoring example for European brands, at least, because Tailorlux made it in Spain, so we have a complete value chain in Europe. But then the US companies came in to buy because they can prove, okay, this is cotton not coming from China. So I think I'm not really sure what the intention of a brand is, and we are also not in the forefront to market this to brands. I think when Koen is speaking about this, I think that's a question for him, because they are really really close to the brands, where you think in purchase orders and not in inorganic tracers and how to implement them.
Okay, and because yours is an IoT-enabled technology, it links to a digital twin, right? Data becomes imperative, and security of that data everybody wants. Could you just share what security assurances you have in place?
Security assurances means that the technology cannot be copied or
cannot be copied, and the data for every manufacturer is secure. Like, is it ISO certified?
Okay. So we have not certified the technology as such. So there is no security standard. I can just say like, this is it. I can just say it's a very agnostic, very flexible solution. So it can be rolled out in whatever environment you choose. So the data security part is something that I have to pass right now because I have to ask someone from IT who can really do that. Sorry.
That's absolutely fine, no problem. So, okay, tell me, like, what's next for Tailorlux? Like, you've been, I understand, I mean, your expertise is textile segment, but as a business, as a tech player, what's the future? What future developments you're looking into?
So we are now looking at the near-infrared technology, near-infrared spectroscopy, as a very exciting part, especially when it comes to detecting contaminations in recycled cotton, but also to sort, post-consumer waste, because this is often a very, let's say, handheld process. There is no real machinery, or you just need to invest in a very big technology park, and we want to enable every user to use spectroscopy and to make sense of what they see. So that is a journey that we just started to onboard different materials on our NIR data base, and then have these data in the field in order to see how it really works when you have it in a live environment where people are getting confronted with all kinds of material blends, and then you need to decide whether this is really PET or a polycotton or whatever, and how this device can help. So that is one direction that we are going in, and this is of course followed by the use of machine learning. This is something that we started 2 years ago, that we want to create machine learning models on how to also quantify the tracer fiber in a garment. Because when you have the tracer fiber in a garment, you cannot just point to any spot on the garment and then maybe see an LED indication or something to show that this is a blend of something or that there is a missing signal. Because this spot is not representative for the garment. So you actually need another method. And this is something that we have developed also with the near-infrared technology and the visual spectrometer, to have a composite signal that can really tell the user after a few scans, this is a 50-50 blend, this is an 80-20 blend. So that is, these are the two directions that we are looking in. One is near infrared, the other one is tracer quantification in tracer fiber scenarios. Okay,
so that's very interesting. So the new technology, and I think it goes back to one of the questions previously, which was around percentages, that technology would give that signal what percentage those blends are, because currently, if I understand it correct, it tells you the predominant fiber, but not the actual mix?
Yes, so when I have, let's say, so this is a marked PET fiber, and if we can make this now visible, the tracer that is in there visible, we would see a very even signal because it was in an extrusion process all over the garment, so all over the yarn. So it would be very easy to take a look at one spot and say that this is representative for the rest. So that is done. That is easy. The quantification, or we call it categorization, that this is an 80-20 mix or whatever, is valid. That is possible. That is not rocket science. It is more difficult in a cotton yarn when you have like 0.1% of tracer fibers in there, and even the homogeneity is very nice. It will always be chaos inside here, signal-wise. So if I'm looking at 1 or 2 spots I might not get the representative composite signal of what is in there. So that needs a more sophisticated approach by looking at various spots and a specific number of spots. But you could also use a camera technology, which we are currently working on, to have the real figure of, is this an 80-20 or is this a 70-30? And I think these are the categories that matter. So we don't want to claim 71.5%. We want to categorize these yarn blends of 70-30, 80-20, because we think that they are the relevant ones for the recycled cotton or the industry as such.
I do have one last question, Tobias, and this is from the audience. And it's around, can the technology be used in viscose? And if so, what percentage of tracer per kilogram of yarn would be required?
Can it be used in viscose?
Yes.
Then I made something wrong with the presentation. The use case that I was describing is actually dosing viscose. Dosing viscose in a super small percentage. So we are talking about 0.0, 0.2%. And I'm sharing this slide again.
Please. Yeah.
So this murky device here on the left, that was developed by Tailorlux. It's a fiber dosing device, an IoT connected fiber dosing device, and it actually doses viscose filaments, which will be crimped and cutted to staple fiber in order to precisely dose these viscose, these enriched viscose fibers to the shredding machine.
Okay. Other question just linked to this now is there a particular staple fiber length that the technology can work on, or even with smaller lengths?
So we are adopting the viscose fiber length to the use case. So if you have a recycled fiber, you will have a shorter tracer fiber. If you have an extra long staple, it will be longer. So this is a patented technology with this dosing device that is created to cut and crimp filament in any length.
Okay, understood. Okay, I think that brings us to the end of our session. Any closing comments you would want to make to our audience around traceability, or the future of traceability, where you think the industry might be next couple of years?
I should have been prepared for this one, but I'm not. So now I think it's very interesting, and the agenda also shows that there is a new balance coming in. So digital traceability is good, is something that you should consider anyway. But looking beyond is something that really brings additive tracers into play. And of course, I'm super happy if someone decides for inorganic tracers, because I think there are good reasons for that. But also like DNA tagging, I think all this will become more and more relevant. And yeah, I'm looking forward to this, and I'm really happy to work with the front runners. But I think that the rest will also come depending on how forceful the legislation will be now, which is coming.
Yeah, perfect. On that note, we end our session today. So thank you so much, Tobias. It was an interesting presentation, especially the discussion was interesting when you demoed the tool, and we could understand how actually it would work rather than just going through the slide deck. And I'd also like to thank Tailorlux, because you've supported us with your sponsorship for the event. So thank you so much for that as well. If in our audience, if you have any further questions for Tobias, please put it in the comment section, and we will forward them on to Tobias, and he can sort of connect back to you with the responses. So thank you so much, everyone.
Thank you.